On this video, I will discuss composition of functions. A combination process unique to functions is to compose the functions. To compose the functions, a function must contain a function, or a function must consist a function. The composition of functions f and g is a function denoted by f circle g, where f circle g is also the same as f of g of x. The symbol f circle g can be read as f composed with g. However, both f composed with g of x and f of g of x can also be read as f of g of x. Example: if f and g are defined by the equations f of x is equal to x squared and g of x is equal to x squared plus 3, find f composed with g of x, g composed with f of x, f composed with f of x, and g composed with g of x. First, let us have f composed with g of x. So it means that the function f must contain the function g. So let us get the function f. So we have the function f, which is x squared. So from this function, it must contain, or it must consist, the function g. So how is that possible? So we must replace the x variable with the function g. So that is now the quantity x squared plus 3 squared. So evaluate it further. X squared plus 3 squared means x squared plus 3 times x squared plus 3. So this is a product of two binomials. So we can apply the FOIL method. So it stands for first terms, outer terms, inner terms, and last terms. So for the first terms, x squared times x squared is equal to x raised to 4. For the outer terms, x squared times 3 is equal to 3x squared. Then for the inner terms, 3 times x squared is equal to 3x squared. Then the last terms, 3 times 3 is equal to 9. Then, simplify it further by means of combining similar terms. So from this, the similar terms are 3x squared and another 3x squared. So that is now x raised to 4 plus 6x squared plus 9. Next, we have g composed with f of x. So the function g must consist the function f. So we have the function g, which is x squared plus 3. So this function must contain the function f. So let us replace x with x squared. So that is now x squared plus 3. So x squared means x squared times x squared, which is equal to x raised to 4. Then plus 3. So we cannot simplify this anymore. Therefore, that is the final answer. Next is f composed with f of x. So the function f must consist the function f itself. So get the function f, which is x squared, then replace x with the function f, So that is now x squared squared. So we have already solved that a while back. So that is x raised to 4. Then we also have g compose g of x. So the function g must consist the function g itself. So getting now the function g, that is x squared plus 3, then this function must contain the function g. So replace x with x squared plus 3. So that is now the quantity x squared plus 3 squared plus 3. So x squared plus 3 squared is x squared plus 3 times x squared plus 3. Then copy plus 3. So notice that that is also a product of two binomials. So we can use the FOIL method. So for the first terms, we have x squared times x squared, which is x raised to 4. For the outer terms, x squared times 3, which is 3x squared. For the inner terms, 3 times x squared, which is 3x squared. And for the last terms, which are 3 times 3, which is equal to 9. Then copy plus 3. So combine the similar terms. So we have 3x squared and another 3x squared. Then we also have 9 and 3. So copy x raised to 4. Then 3x squared plus 3x squared is equal to 6x squared. Then 9 plus 3 is equal to 12. Therefore, g composed with g of x is equal to x raised to 4 plus 6x squared plus 12. Another set of example. If f and g are defined by the equations f of x is equal to x minus 1 and g of x is equal to x squared plus 1, find f composed with g of 4. So from this example, there is already a given value of the x variable. So in getting f composed g of 4, we have two ways on how to solve for it. So for the first one, we need to first get the f composed with g of x. And then the resulting function will be evaluated with x value of 4. So getting now f composed with g of x. So x minus 1 must contain the function g, which is x squared plus 1. So let us replace x with x squared plus 1. So that is now x squared plus 1 minus 1. So 1 minus 1 is equal to 0. Therefore, f composed with g of x is equal to x squared. Then, get f composed with g of 4. So let us replace the x value with 4. So that is now 4 squared. So 4 squared means 4 times 4, that is equal to 16. Another, first, we need to get g of 4. And then, the resulting value will be plugged in into f of x so that we can satisfy that the function f must contain the function g. So we need to get first g of 4, then the resulting value will be plugged in into f of x. So getting now g of x is equal to x squared plus 1, find for g of 4. So replace x with 4. So that is 4 squared plus 1. 4 squared is equal to 16, then plus 1 is equal to 17. Then, plug in this value into f of x. So, we will find f of 17. So, f of 17 now is equal to x minus 1. So, replace x with 17. Therefore, that is now 17 minus 1. So, 17 minus 1 is equal to 16. Of course, the result from solution A to solution B is just the same. So, no matter what process you're going to follow, as long as you have the right process, you're going to arrive on the same answer. So, that is the composition of functions. Thank you for watching, and I hope you have learned something.